Testing. Oh, there we go. Okay. That took way too long. I noticed that my mic was not working. Took a little bit to get it going. Okay. So, couple questions. Do we get the same pointer to the file name across X open calls? I'm curious about that. How can we lock? Um, how do we get exclusive access? Yeah. These are kind of like questions in my head at the moment. How do we do this? Okay. Let's look into the first one to see for X open. Do we receive the same pointer? I'm just going to use two of the same threads. Let's say info. Well, trace is fine there. Info and trace. Yeah, that should work. Okay. I want to know if this is the same pointer. So here, nope, Z name. Where is Z name? Z name's there. So check. Let's remove that and try again. We want to make sure we have a clean set of logs. There we go. One of the processes is basically getting starved for DB access. So we're looking for our X open calls and Z name. 13D here. This is what we're looking at. 13D is 008C04. Yeah, BA4. Okay, so the Z name's slightly different. And this is for insert mini DBs. This one is for the wall. Wall. Okay. So the name's actually different. The pointer. That's okay. That's okay. Essentially, what we need to do is when we receive one of these and we're setting up our wall log, we need to be able later, as we're rotating the wall log, to signal, hey, we need exclusive access on this thing. The way that that's currently happens is by performing a lock. Let's see, where is this information? Let's just use this one for a moment. Documentation. We're going to look at shared memory lock. Oh, separate. Okay. So this is for wall mode. Oh, getting bugged again. One minute, please. Back to fun. All right, so we're going into documentation. We want to see programming interfaces. And actually, oh, okay. I want to continue that. So the wall mode and file logs. Let's take a look at that. Sorry. Stuff just keeps coming up this morning. All right. 8 bytes of space are set aside in the header to support file locking. Okay. These 8 bytes are never read nor written by SQLite, since some VFSs might implement locks using mandatory file locks. Okay. Now, this is for the shared memory section. Fascinating. Is this documentation, programming interfaces? We want to look at list of objects. So on the file IO objects here, this is the P methods. We have map and lock, but I don't think that we're actually seeing this called on the wall log. We only see this called on the main DB. Should be able to validate that. See, this here is the main DB. See, wall SHM lock doesn't show up. We do see it from the main database, though. Over and over and over again. I'm distracted again. I might have to go early today. No. All right. I'm going to take a little bit of a break. Let's see. All right. Well, let's see. I might be able to get a little room here. So when we initialize the state, find or create, actually, I'm very interested to know whether or not the SHM lock bits on, right, if this information here is the same. Does this call the same thing that is called on the main DB? So let's say I call this on the wall log. Does this point to the same location as the main database? That would mean, so we could try that. So we are seeing some locking happen. I'm not sure the order in which we need to do it. Do we need to do a barrier first? Do we need to call that? And then a lock, and then a file control, lock, barrier, lock, blah, 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 right? I suspect not. But I am kind of curious to understand what's happening here. Let's grab this, go to the next one. Actually, let's do two, because I suspect that starting is halfway in this. Oops. Did that go into the copy buffer? It's my bug notes. Did. Good. Yeah. Let's figure this out. Let's get rid of the beginning bits. Let's make this more usable. Let's go up to here. There we go. Much better. So I can see if it's wall, if it's main DB, and what's happening. So we write, we sync. That's good. Then we do a SHM barrier. What does SQLite say this is? Let's look at the code. What are we doing here? Okay. All loads and stores begun before the barrier must complete before any load or store begun after the barrier. Okay. This is just ordering, right? Why would we define memory barrier? Okay. Enter mutex, leave mutex for redundancy. All right. So we have a barrier. And then just going to grab this here. Now the SHM lock. Now this is for offset 0, N1, flags 9. So we have to look up, where's our secret decoder ring? Where's secret decoder ring? X open, lock and unlock are, nope, that's not what we want. Oh, it might be in here. Flags, here we go. So you can lock shared, lock exclusive, unlock shared, and unlock exclusive. Okay. Interesting. Lock, unlock, exclusive or not. So what are we saying? N and flags. Flags 9 at N1. Lock method can transition between unlocked and shared, or between unlocked and exclusive. It cannot transition between shared and exclusive. What? Unlocked. Okay. Da-da-da-da. So then we lock offset 0. What's offset 0 though? Let's grab this. I'm going to make this look like a comment. There we go. Same up here. Oops, too much. All right, so offset 0 and 1. Where do we get that? It's like scattered all over their documentation. I'm glad they have so much documentation. It's just, you have to kind of pick through it occasionally. Here we go. See, this gets me though. These 8 bytes are never read nor written. I guess we're not reading or writing them. Just doing a lock. What does that do? Okay, first, let's see. Grab this. Name offset. Ah, okay. So the offset in the file and the offset in the SHG unlock. Interesting. There's a file and shared memory lock. Okay. So next question. Let's, mm, let's do this. Why can't I? Hmm. I have some tabbing going on. Oops. Oh, that's easier to parse now. Okay. So first thing we're doing What is this? Offset 0. So we're looking for a write lock. N1. What's N? And flags. 9. Exclusive unlock? Hmm. So what is N? N there is interesting. Don't know what N is. You can see which file it is. Okay. Offset. So for this one, this is offset 0. All right. Lock. And flag 9 is exclusive unlock. We do a file control. Not sure what that's doing. Then here, let's fill in some of these shared memory locks. Offset 4 is a read lock. It's a all read lock. Flags 5 would be shared unlock. Huh. A memory barrier. Now in this case, we'll read lock. Flags 10. Exclusive lock. Okay. Now these are all for the same file. Yes. One. Yes. Now for this one, sorry, still a little distracted. Offset 4. So another read lock. Oh, yeah. See, I was distracted. It was right here. Just did it. Flags 9, though. 9. Exclusive unlock. Interesting. Why the unlock after the lock? We didn't see anything else. Is that just ensuring that nobody else had an exclusive lock on it? So we did a read, an exclusive. So we unlocked shared, locked exclusive. Offset 4, read lock, flag 6, new combination, or 2, shared lock. Barrier, shared memory unlock, 0, that's wall right lock, wall right lock, flags 10, exclusive lock. Okay. N for these is always 1. Don't, what is N? Int N. Okay, let's look at their source. Map lock must be around this code. Perfect. Number of locks to acquire or release. Oh, okay. Oh, I see. So you could say I want to start at N or at offset and get a bunch of them. Got it. Okay. Interesting. Take this. This is a good bit of documentation. That's what I was going for. Okay. What next? So then we have the exclusive lock. Basically, we coming off of a change, right? We did a change, and then we exclusive unlocked, read lock, and unlock. So this was shared, exclusive, shared, all right lock. So now we're getting another exclusive lock just before we make another change. Fascinating. Oh, we should check the first change. Interesting. First thing we do is shared memory map That's important. Okay. Shared memory map. Sorry for my distraction today. Size. Page 0, page size arg1, 2, 0, and 1. Arg2's the same. Looks like I can set that to nothing and return to 0, to nil, return 0. Seems like we'll have to do the same thing. Shared memory map. Then we do our locking. 10 was 10. Exclusive lock. Do we map again? Barrier. Lock exclusive. Oh, offset one, number 2. Look at that. We ended up locking 2 things. Offset 1 and offset 2. So we did offset 0 first, then offset 1 and 2. So we got the write lock, the checkpoint lock, the recover lock. But we didn't touch any of the read locks. Interesting. Here, though. Read lock. Read. Yeah. Looks like we're trying to get a whole bunch of locks. Actually, this is a lock and then an unlock. Lock, unlock, lock, unlock. Lock, lock. 2 and 4. That was lock, shared. Offset 3. I feel like I need to understand this locking mechanism a little bit better. Basically, I need to make sure that everything's locked so we can rename the wall log, which should be enough to kind of mimic what they're doing before they write to the wall log. They do some writes, and then let's see, flag 9, that's exclusive unlock at 0. 5 shared unlock at 4. Exclusive lock at 4. Exclusive unlock, shared lock. At 2 was lock. Yep, lock, unlock. So evens and odds for unlock. And now we write. It's interesting that did we see 2 and okay, so where was it? Here's this. So starting at offset 1, we locked 1 and 2, right? Because the number of locks. And what was it? So the recover lock. I don't remember seeing this get unlocked. So we have a checkpoint lock. Right? This is for copying data back into the main database. This is for doing just file recovery. Where's number 2? There, we lock it. Exclusive. Ah, here. There's the unlock. Okay. So far, I've seen that we need to set up. Right? We have the shared memory map. We'll have to figure out how to do that. Extract it again. So we need to do some sort of mapping, some locking. I don't know if this ever happens again. Let's check for that. No, it only happens at the beginning of the file. Locking those two. So this could have been a check to see whether or not we were doing a recovery, that sort of thing. Just some standard startup stuff. Okay. So we do our mutation and then barrier, lock. Let's see, this is, what was zero? Zero was a right lock, wall right lock. It's wrong place. Here, unlock, exclusive unlock, file control. This is read for wall read lock. Shared unlock. Exclusive lock. Okay. I want to find the code here. So when SQLite performs a lock, what are they doing? Or a write, what are they doing? I want to scroll up all the way. I just there. X write. See some JS stuff. OS Unix. We don't want that one though. We want something like this. So it ends up calling write, which is fine. So maybe we look for references to SQLite 3 write. Okay, let's try that. Where'd it go? SQLite 3, right, this guy. And journal backup pager. Could be the pager references. Show more. Yes, the pager references. Step into here. Write 32 bits. Okay. What's going on? Here is zero journal. 0 journal header. Is that when we go to locate? Where else? We have right sync. Right journal. We're still in right journal header. Okay. Probably should just scroll through. 32 bits. Right. Okay. What else? Coming up on another one. Pager playback 1 page. Interesting. What's this one? Delete super. Okay, yep. It's for some magical stuff. Out here. Static journal. Sync journal. Make sure all pages have been written. Good. Is there like a write journal? Sync journal. Right page list. Open subjournal. You're right. Mark a single data page as writable. Else. Page right is interesting. Page right, large sector. Increment change counter. Okay. Pager sync. SQLite 3 pager exclusive lock. This function may only be called while the write transaction is active in rollback. The connection is in write-ahead logging mode. This calls a no-op. Okay. We have here SQLite 3 pager commit phase 1. Wow. And phase 2. So pager is kind of interesting. I don't know. Let's see. What I'm looking for is maybe there's an interface for being able to just say, hey, I want to lock this. Like some higher level interface. Control. Low level control of database files. It gets you pointers to things. Okay, that's not it. SQLite unlock notify. Busy. Changes clear bindings. Okay. Control. We looked at that. Value. That's not it. Let's look at objects. So we do have access to SQLite 3. Not what I was thinking. I was thinking this one. API routines. Here we have our P methods. The DFS though. What does access do? Just more disk IO, right? Does the file exist? Is it writable? Is it readable? Back one. IO methods. This is the one we love. Really hoping for something higher level. What does fetch and unfetch do? Well, I'm going to dig around a bit. I'm going to end the stream a little bit early. It's been just mainly kind of searching for an answer. I'm not seeing it. I am kind of curious what this does, though. Memory mapped IO. Interesting. Okay. So that's for memory mapped IO. Just lock and unlock. I just looked right over those. Lock upgrades the database file lock. In other words, xlock moves the database file lock in the direction none towards exclusive. Okay. The argument to xlock is always one of shared, reserved, pending, or exclusive. Never none. The database file lock is already at or above the requested lock, then the call to lock is in no op. Xunlock downgrades the database file lock to either shared or none. The file lock is already at or below the requested lock state, then the call is in no op. Check reserved lock method checks whether any database connection, either this process or some other process, is holding a reserved, pending, or exclusive lock. I could probably just use these. Haha, there's the solution. And he walks away. X file control method is a generic interface that allows custom BFS implementations to directly control an open file using the SQLite 3 file control interface. The second op argument is an integer opcode. Third argument, generic pointer to a structure that may contain argument or space in which to write return values. Actual uses for it might be functions to enable blocking locks with timeouts, to change the locking strategy, to inquire about the status of locks or break stale locks. Fascinating. Okay. I don't think we have to do that. I think we can just rely on lock and unlock. Now, does it... wonder. Would we ever... Because we're going to need to go to exclusive. What is reserved? Shared, reserved. Is this just some bit that's reserved? Or is this something else? Let's take a look at Unix lock and Unix unlock. Sometimes when requesting one lock state, additional lock states are inserted between them. File lock. P file. Not sure what that is. Mutex enter. I don't know if we can use this. Is this just a file log? Lock. Hmm. So this does not actually interact with the shared memory locking. Oh, that's a bummer. Okay. Boo. All right. Well, I got a bit of research done. Do I port the whole SQLite to Rust? No. I'm simply building a virtual file system for Rust in order to do kind of physical data replication. All right. I gotta run. It's been fun, y'all. Sorry for the distractions today. Hopefully it'll be better the rest of the week. We'll see. All right, y'all. We're gonna rate Adam. Y'all take care. Bye bye.